And again, there are two parts to this lesson. We might go through the first example and I'll consult you guys. I think you'll feel pretty happy, and we might just do all of the notes at the start and then just proceed through both exercises at our leisure. So we're doing 2D lesson 2, and here we are, we got our first example. Now let's just point your attention to this table, because what we're drawing out, the reason we're doing the exercises differently is we're trying to point out there are 3 ways we can express a quadratic equation. We're very familiar with this, ax squared plus bx plus c. We call that general form, and that reveals to us instantly the y-intercept. Remember, the y-intercept occurs when x is 0, we put x is 0 in, we have y is c, the y-intercept is c. We also know how to factorize it. If we factorize it using the cross product method, we can get to axis-intercept form. We also call that linear factors, and that tells us the roots. They're the x-intercepts where it crosses the x-axis. So you can see both forms reveal useful things to us. What we're looking at today is the third form, which is a completed square. Now we solved quadratics by completing the square, but the process today will be a little bit different because we're not solving an equation, we're just completing the square for a function. So it will be a little bit different. This is what the quadratic looks like in a completed square form. And what it reveals to us is the coordinates of the vertex, HK. So if it's written like this, HK, the coordinates of the vertex are H and K. So if we have a look at this quadratic over here, let's just draw out those features from a particular example. We can see the roots, the x-intercepts are x is -1 and x is +3. Those are the x-intercepts. The y-intercept, where it crosses the y-axis, is -4. All right, notice the y-intercept occurs when x is 0, and the x-intercepts occur when the y value is 0. This coordinate here is called the vertex. That's the lowest point, or if the quadratic's going downwards, that's going to be the highest point. Okay, we call that the minimum. And the coordinates here are x is 2, y is -6. And what we also know is that this point, it's exactly halfway between those roots. All right. In fact, it's what we call the axis of symmetry. All right, axis of symmetry, because about this line, the function is symmetric. That's why it's called the axis of symmetry. One other thing we noted is that if A, the number out the front, is positive, we have a smiley face, and if A is negative, then we have an opening downwards. So we see both shapes with the parabolas. Okay, so that's a recap. Let's get straight into our first example. Now this one, the square is already completed. We don't need to change it. It's already expressed in this form. So part A says, part 1 says, determine the coordinates of the vertex. So the coordinates of the vertex are HK. So in this circumstance, it's going to be x is 1, y is -4. All right, the coordinates of the vertex are HK. Now, if this is the coordinates of the vertex and we're asked, well, what's the equation of the axis of symmetry? Well, the equation of the axis of symmetry is just going to be x equals, and the x value of the vertex will always be the x value of the vertex. The equation of the axis of symmetry is x is 1. Okay, part 3, find the axis intercepts. This means the x-axis intercepts, where it crosses the x-axis, and the y-axis intercepts. So let's do the y-intercept first. So for part 3, we'll say y-intercept occurs when x is 0. So we're going to put x is 0 into this equation. All right. So I've subbed it in, and now we will process it. This becomes -1 squared. Now -1 squared is +1, and +1 take 4 is -3. We have a yint, the y-intercept is -3. Okay, so that's the y-intercept, that's where it crosses the y-axis, but we're asked for the axis intercepts. So that's where it crosses the x-axis as well. Now remember, we drew it out before. The y-intercept is when x is 0. The x-intercepts occur when y is 0. So we can find the x-intercepts from completed square form. We just need to process it a bit. If this is the function, well, the x-intercepts occur when y is 0. So we're going to put 0 where the y is. And now we're just going to solve this equation. Alright, so we have 0 equals x take 1 squared take 4. Now the way we solve this equation is we're trying to get this term by itself. So to begin with, we're going to plus 4 to both sides. Now you can put the 0 on the left. Lots of people prefer it on the right. It doesn't matter because if it's equal to 0, if they're equal, it doesn't matter what side we write it on. So we'll start by plussing 4 to both sides. Now this is a skill we did do in 2A3. We solved equations like this. So we're just recapping it now. We'll square root both sides. That's going to give us plus or minus 2 over here. The square root of 4 is plus or minus 2. And then we'll move the 1 over. X is equal to 1 plus 2 or 1 take 2. That's the plus or minus. And we'll evaluate both of those. We'll have 3 or minus 1. Alright, so we've done part 1, part 2, part 3. Graph the quadratic. So we're looking at using our algebraic techniques to graph this quadratic, right? So this quadratic is very similar to what I've got sketched up here. I'll just rub it out quickly. So we have x is negative 1 and x is positive 3 are our x-intercepts. So here's negative 1 and here's positive 3. We have a y-intercept of minus 3, that's going to go there. And we have a vertex, the coordinates of our vertex, x is 1, y is minus 4. So across 1, down 4, that's going to be about there, that's the coordinates of the vertex. And we have all of the features that the parabola is going to travel through. So it's going like this. Alright, now whenever we sketch a graph, alright, we need to make sure we're labeling our axes, x and y. We label the function. The function we have is x take 1 squared take 4. Alright, we always need to have all of those features, especially the features that we've found, 1 and minus 4, in order to draw the graph properly, in order to get full marks. Okay, so we plotted the x-intercepts, we plot the y-intercept, we plot the vertex, we draw the parabola going through it, and then I've just gone through and labelled everything. Okay, any questions about the first one there? Alright, so basically that's the first skill. So let's consult you guys. Do we want to just keep going on with the next 2 examples, or would you like to stop and do the skill first? What do we reckon? What's the general consensus? Okay, just show of hands. Who would like to stop and start the questions? Cool. Who would like to continue? Excellent. All right, so we'll just continue on to the next example. So our next example is given to us in, let's have a look at it and see if we can identify. We have y equals x squared take 6x plus 5. Okay. So if we're going to, this is a type of quadratic, we can recognize it's a quadratic because the leading power is 2. And so if we're looking, what form is it? Is it like this, this, or this? It's in general form. It's expressed to us in general form. So that means we need to complete the square. All right, so your role here is going to be to complete the square first. Now, it's a little bit different from when we were solving equations by completing the square. What we're going to do, I'm just going to set it up like this first. We're going to have x squared take 6x, and then I'm just going to move the plus 5 over. Maybe you'll remember what we're doing when we complete the square is we're going plus b on 2 squared to both sides of the equation. Right. However, so I'm going to go plus, and then the b value divided by 2. Squared. So we would normally plus it to both sides of the equation, right? However, here we don't have an equation as such that we're solving, we have a function. And so because we've gone plus that amount, we also need to go take away that amount. So that's the only difference, is that we add b, so b, I'm getting that number from here, okay, minus 6. We add minus 6 divided by 2 squared, and because we added it, we subtracted it as well. We've maintained equality, we haven't changed the value of the function. All right, now we'll just process this a little bit. I'm just going to write it like this to show you the completed square. So this is not a necessary step, I'm just trying to draw out the connection. Here we have 2 times x times 3, and here we have 3 squared. Over here we have plus 5 and take 3 squared. So this here is a perfect square. It takes this form. A take b squared, a squared take 2ab plus b squared. All right, if we look, this is how it's presented to us. We have x squared, take 2 times x. Okay, that's popping up there. Times 3, and then plus 3 squared. We've manipulated it intentionally so that it's a perfect square, so that we can move from there to there. So we're going to move from here to x take 3 squared. Okay, that whole part is the perfect square, so it completes to here. Okay, so when you've got it written out like this, okay, we can recognize that simplifies to 3. I've done the perfect square rule, so it's going to x take 3 squared. Over here we've got 5, and then take away 9. 5 take 9 is going to be minus 4. And we've successfully moved from general form to completed square form. All right, great success. Okay, let's go about performing what it wants us to do. Determine the coordinates of the vertex. All right, so the vertex is HK. So in this circumstance, our vertex is x is 3, y is minus 4. Okay, state the equation of the axis of symmetry. Remember, it's always x equals, and then the x value of the vertex, so 3. Find the axis intercepts. Well, we can find the y-intercept very easily. All right, we don't have to perform the process we did last time because it's given to us in the first step in general form. We can see the y-intercept right here. The y-intercept is 5. Now you could process it here if you want to, right? It occurs when x is 0. We put 0 in there. We have 3 squared is 9. 9 take 4 is 5. All right, so you can process it like that. You'll see all these connections, but it is revealed to us right at the start. Okay, next the x-intercepts. The x-intercepts occur. Now here I want to point out the connection between the two processes that both are going to reveal to us the answer. Let's do it first for completed square. If we have x take 3 squared equal take 4 is 0, if we're going to solve this equation, right, we want, why have I said that like that? The x-intercepts occur when y is 0, so we've set 0 where the y is. We'll move the 4 over. We're going to square root both sides. We'll move the 3 over. Five or 1. Okay. So we've got the solutions that way. However, I want to draw out a connection as well, is that when it's expressed like this, we learnt last lesson that we can factorize that. If we have x squared take 6x plus 5, all right, if we're going to factorize it, we're looking for two numbers that multiply together to give us positive 5. And when we add them together, we get negative 6. So that would be minus 5 and minus 1. And when you apply the null factor law, we get those same solutions. All right, so when you're at this stage and you're asked to find the x-intercepts, you can do either process. This one probably requires a bit more thinking because you have to go, what are the factors that give me 5 and add to -6? Whereas here, all you're doing is solving the equation, moving it over, forming the square root, and simplifying. Okay, we have everything we need to sketch the graph, so let's do it. Graph the quadratic. So, we have a x-intercept of 1 and 5. All right, we have a vertex of 3 and -4, and we have a y-intercept of +5. Okay, so 1, 5, here we've got 3 and -4, and passing through all those points, we'll draw the parabola. Always arrows to show that it's going on forever. Y-intercept +5. Label the axes and label the function. So you can either give it this label or this label, both are the same. X take 3 squared, take 4. Good? Okay, so that's the process there. So in the first part of the exercise, you'll be given a completed square. In the second part, you will need to complete your own squares. So I expect that's where we might find it a bit challenging, and I'm happy to go through a few there if people are finding it. Just flip the page over because we have one more example for us. We given a graph, so this is example 2. We're given a graph and we're told to determine the equation of this quadratic. All right. Now this is -2 and -4. And we're going to determine it in completed square form. Well, we know completed square form is like this. X take h squared plus k. That's the default completed square form where h and k are the coordinates of the vertex. So that means h is -2 and k is -4. I'm going to now substitute both of those into our default form here. So it's x take, and then the value of h is -2, so it's x take -2, and then -4. So that will simplify just to be +2. You can do it in one step or over 2, doesn't matter. All right. So there we are, but we still have this a out the front, and we always need to solve for this a. That's the dilation constraint, right? And so we need to use any other piece of information that we're given here. Now we're given 2 pieces of information. We're given the roots. Here we have when x is -4, y is 0. And here we have when x is 0, y is 0. So you can substitute in either of those to find the value of a. Both will reveal to you the same value of a. Let's go 0, 0. So I'm going to put y is 0, and I'm going to put x is 0. And you're just solving this equation for the value of a. What we'll do is we'll +4 to both sides. Divide both sides by 4, and we have a is 1. And so therefore the equation of this quadratic, the a value is 1, so we have x plus 2 squared take away 4. Now again, we can use our calculator to help us out. We can sketch this, trace along it, and confirm that it has the same features that we're required to find. Your graphics calculator is your pal, right? But we still need to know, comprehend, and able to follow these processes. So that's all. That's our 3 examples. We start with, again, we'll have a look at the front of our notebook for our checklist. We're 2D lesson 2, so we're graphing from completed square. So the exercise we're doing to start with is 2D.1, question 4 and 5. All right, that's where we'll start, and then we move on to 2D.2, question 1 and 2. Excellent. That's our lesson.